Hey everyone, and welcome to our day 3 of Array and String Mastery series at Aarush Coaching Classes. So let's have a quick recap about what we have done till now. So in the last class, we covered array traversals with two pointer, then pair some in sorted arrays. This was a problem that we discussed, you can say, with the major part. Why? Because this was one of the most important problem which is mostly asked in the interviews. So we worked upon it, and with three approaches: the brute force, the hashing approach, and the two pointers approach. These two approaches were more like the hashing was better than the brute force and was working on unsorted array as well. Okay, but then we had the most optimized one, which was a two pointer, but this was applicable on the sorted array only, because if you want this particular technique to work, you would have to have the array sorted first, and sorting it itself takes big of n log of n. So anyhow, this is greater than the time taken by the two pointer technique. So that's why this won't work on unsorted array. Okay, this won't work on unsorted array. So please try to remember that. And in the last class as well, we discussed upon the time complexity and space complexity concepts as well. I showed you what was the space complexity: any extra space that is used to solve the problem, okay, to reach the solution in order of the size of the input. Then only you will consider it in the extra space, otherwise no. Otherwise that space would be constant space if it is very small. Okay, time, it was number of times we were running, or you can say number of iterations we were having in the loop, correct? So that's what it was. Now let's move forward and come to this point where we what we are going to cover today. Let's focus upon this. So these are two majorly asked problems. Majorly means majorly, too many times it have been asked in most of the interviews in all the big tech companies, including the farm companies. Okay, so continue with the most water problem, and the other one is a trapping rainwater problem. Too many students try to solve this using the brute force approach, but they don't understand the idea of how to optimize it. So don't worry, I will explain it today properly. Okay, so anyways, the advanced pointer movement logic is gonna be used in this particular problem, so please be focused in this whole lecture. That's what I really need you to do. Okay, and anyhow, this is being used for optimization, so it is also happening, and I will share a few problems on the similar pattern that you can try on your own and which have been asked in the same kind of interviews. Okay, so let's have a quick warm-up challenge. Why? Because though I am going to discuss the similar kind of problem, but before that I really want you to think about it first. Give it a you can say thought properly. Why? Because me reading the question and then giving the answer directly doesn't work for you. Why? Because अगर ऐसा होता तो सारे वीडियोस देख के ही सब लोग टॉप कर जाते हैं. मीन्स ओनली वॉचिंग डजेंट मेक यू स्मार्टर और कैपेबल इनफ टू सॉल्व द क्वेश्चंस विच आर गोना बी आस्क्ड इन द इंटरव्यू. At the end of the day, what matters is the thought process. Okay, thought process, and this gets built only when you have solved enough problems and brainstormed on the problem statement as well, like what it is actually asking. Okay, so here the heights are gonna be given in the form of the array. Okay, which two lines would form from the container, would form the container with most water? Think and comment. It is what I want to. I know that these lines are not enough for you to understand the question directly, but that's why I have written here, because most of the time basic questions are like this only. You would have to push your imagination to understand what is actually being asked. You would say, sir, where is the container? So actually the height of the there is no physical container actually, but these items in the array are showing the height of the lines, and as you know that array is represented in this way, correct? So let's say 1 8 6 2 5 4 8 3 and 7 are the height of the lines, you know. lines are given here. This is zeroth line. Let me change the color. This is zeroth line, first line, second line, third line, fourth line, fifth, sixth, seventh, and eighth line. Okay. So if I were to draw, the first line would be looking like what? Because this is very smaller. यहाँ होगा ऐसे एक एक्सेस जा रहा है, ठीक है. 1, then there is 8, 8, then there is 6. Okay, so 6, then there is 2, then 2 is there, then there is 5, there is 5 there, there is 4, 4 is there, then again 8 is there, then again 3 is there. Okay, so 3 would be somewhere here. Okay, then there is 7, so 7 would be somewhere here. Now you can see that all these lines have been drawn. The numbers are nothing but representing the height of the line. So again, this is the zeroth line, this is the first line, second, third, fourth, fifth, sixth, seventh, and eighth. Now this is what I really wanted you to imagine about this problem. Okay, now if you look, the base here, because in the question they said which two lines would form the container with the most water. Two lines are gonna do nothing but they are gonna be boundaries of the container. Okay, boundaries of container, and you can assume that this x-axis is the base, of the container, base of container. Okay, now you can understand that if I were to fill the water, then I would be doing it like this. यहाँ पे अगर वाटर फिल करते तो कैसे फिल करेंगे? लेट्स से अगर रेन हो रही है, ठीक है, अगर रेन हो रही है, लेट्स से, then because one boundary is made by this line which is of height 8, one boundary is made by this line which is of height 1. So obviously you can't store water like this, na, not in the slant way, correct? So the water would be stored under these two walls only, two boundary walls, because base is base. So this much water is only stored, you know? Yes or no? So that's what I wanted you to really imagine. Now let's move on. Okay, I hope this question is clear to you. Okay, what the boundary is, what the container is, correct? Yeah. Now you can think of of the answer which two lines would form the container with the most water, and you can write in the chat. Okay, sorry, in the comment. Now, I mean, the hint is this formula. Why? Because if you apply the basic maths, you can understand that the container, it is considered as a 2D container, not 3D. Correct? Because there is an x-axis and then there are two walls only. Okay, so here what you can do is the area between the two walls. Okay, the area between the two walls, and if the area is maximum, then the water content between those two walls would also be maximum. Okay, so that's what they are trying to say. Now let's move on, and you can write your answer in the comment. Let's have the actual problem. Now this is the problem from the lead code, container with most water. Very well known problem. Okay, very well known problem. So let's read it out. You are given n non-negative integers representing the vertical lines, like from the previous slide. Find two lines that together with x-axis form a container storing maximum water. Same thing. Now return the maximum amount of water a container can store. And this is the thing that you need to do. You need to return the maximum amount of water that a container can store, because this is not a 3D container, 2D container only, because bounded by the two lines and the x-axis. So area of the container would be the amount of water. Amount of water is nothing but the area of the container would be water stored. Okay, that's what we can represent. Now note, you may not slant the container. As I told you earlier, if you choose this to be a container, one line, second boundary line, and the base, you can't take water like this. The water will overflow from here. The water can be stored till here only. Yes or no? Okay, so that's why this note is given for you. Now let's read it completely, the whole question. input heights are given for the lines 1 8 6 2. So let me write it. This is height 1, so let me write 1. This is height 8, this is 6, this is 7, sorry 2, this one is 5 4 7, then 3, sorry 8, then 3 and 7. Okay, and what are the indexes? 0 1 2 3 4 5 6 7 and 8. So take 2 seconds, think of some solution, what is coming to your mind, and quickly write in the chat. How are you going to solve it? Don't worry about what is going to be the most optimized solution. Let's take baby steps. Okay, so let's move with the most naive way. Okay, think about it. So we are going to discuss two approaches here. First is naive way and second is the optimal solution. And as we are learning the 2 pointers approach, so obviously it is going to be using 2 pointer. Okay, so let's have the brute force solution first. So what is the brute force solution gonna be here? Let's see. So let me just mark the items again. Height 1 8 6, okay, 2 5 4 8 3 and 7, and indexes are 0 1 2 3 4 5 6 7 and 8. Yeah, so my point was we need to focus upon what? Container. You need two things first. Mark the boundary. Mark the boundary for the container. Okay, and then mark the boundary for the container, and then area equals to water content. These are the two things that you need to focus upon here. Okay, so what I can do is, most naive way would be that I will take the first line as boundary wall, first fixed wall, and then check the area that can be created using this boundary wall with rest of the boundary walls, with the first index and the second index and the third index and the fourth index, fifth index, sixth index, seventh, then eighth, and stores the area, not all the area, store the max area, okay, which would represent the water as well. Okay, so that's what we are gonna do. Okay, like if I fix this boundary wall, means let's say I fix 0, okay, the left boundary wall with 0. If I 0th boundary wall, okay, 0 1 2 3 4 5 6 7 and 8, if I fix the 0th boundary wall as a value 1, then with this 8th first boundary wall of height 8, what would the area? With 8, what would the area? 1 index. So now you can see that the area would be this much only. इतना ही हो सकता है, not the slant. Means you need the boundary height equals to minimum of left comma right boundary. Yes or no? So your left boundary is already fixed with height 1. You are just checking with all the right boundaries, correct? So this first right boundary is of length 8. So minimum is what? Boundary height would be what? 1 comma 8 का minimum क्या आएगा? Is equals to 1. Okay. So this one is the height. What is the area formula? Area equals to height into width, or length into width, whatever you can say, you want to say. Okay, so length we have found for the boundary, वो 1 ही रहेगा, this much only, it can't be 8. 1 is the length, and width क्या है? 1 minus 0. Okay, so length is 1 multiplied by width, which is what? The index score का difference. Okay, 1 minus 0 equals to 1. So area would be 1 for here. So till now the max area is what? 1. Now let's move to the next wall. So let's move to the second index, which is ये हो गया complete. Move to second index, which is item 6. Now with 6 again, what is the boundary wall? Length of the boundary wall, what is that? 1 comma 6. So minimum of among 1 6 would be 1 only. So 1 multiplied by, then width kitni hogi? What is the width? This is length and this is width. Okay, what would the width? Width is the index 2 minus 0. 2 minus 0 is equals to 2 multiplied by 1, 2 only. So now maximum area is 2. Okay, so this way you can understand how much of the area we can achieve at max, because anyway this boundary wall is going to be 1 only, because this is the smallest one. So with this one, this one, this one, this also 1, this also 1, this also 1, this also 1, this also 1. So you can see that length is fixed, it is 1 only, but width is getting increased. So maximum width would be between 0th and 8th index. So maximum area in this, with this first wall we can get is 1 multiplied by 8 minus 0 is equals to 8. This would be the maximum area for the very first iteration. Now that we have found the maximum area with this boundary wall, which is 8. Now let's move to the second boundary wall. What we need to do? If I reach this second boundary wall, I don't need to look at the previous one, we have already calculated. Now calculate the area with the rest of all the boundaries. This one, this one, this one, this one, this one, this one, and this one as well. So now let's see. With 8 length, okay, index I is equals to 1 length is 8. So length would be minimum of 8 comma, from here first boundary wall would be this one, index 2, item is length is 6. Okay, minimum of 8 comma 6 would be 6, and width would be what? Width would be difference of the indexes. So 2 minus 1 is equals to 1. So area would be 6 into 1 is equals to 6 only. Okay, is it greater than the previous max area? No, so we won't update it. Okay, we won't update it. Now let's move to the next one, which is 2. Okay, index 3 and item is 2. So now length would be what? Minimum of 8 comma 2. Okay, is equals to 2. Width would be equals to, index is 3, so 3 minus 1, 3 minus 1 equals to 2. So area would be 2 into 2 equals to 4, again which is not greater than this, so we won't update. Now let's move to this fellow. Okay, so height is 5 and 8. Among these, what is the minimum? 5. So 5 multiplied by, what is the width till here? 4 minus 1, which is 3, is equals to 15. So this time this would be updated to 15. Okay, now once updated, let's move to the next item. Next item is this one, height is 4. Okay, so height is 4, which is minimum of 8 and 4 is 4, multiplied by width would be what? 5 minus 1, 4. 4 times 4 equals to 16. So this time this would become 16. Okay, so now you can see that how we are calculating, and we are just showing the maximum area. If on calculation we are finding the new area is greater than maximum area, then we are updating, otherwise not. So that's what is happening in this code also. If you look at this, first what this loop is for? Fixed boundary line. Okay, the first loop. Now next boundary line we are taking with what? I plus 1th index. From the I plus 1th, like from 0 we fixed 0, but we were checking from the first index and second and third. So here also we are doing I plus 1 and then till the last item. That's what we are doing. Then what are we doing? We are calculating the length, which is nothing but minimum of height of my fixed item and current item, or current line you can say. Okay, fixed and current line. That's how you get the length. Then width, again j minus I index, you will get the width. Okay, and then area equals to length into width, and you need to update the maximum area which was initialized as 0. So if max area and the current area, this is the current area, whichever is maximum you will update it with the max in the max area. Okay, you will update it and then reiterate, then start doing the same for the next item. That's how you will keep doing. Then you will find out that with this particular wall, once I reached here, you can see sir these are the two highest walls. Let's have the area na. तो length कितना आ जाएगा? Length would be minimum of 8, 8 would be 8. Okay, width कितनी आएगी for the this and this one? Width would be 6 minus 1. 6 minus 1 equals to 5. Area would be 5 times 8, 40. Correct? But let's see which is the next one that you want to check. I know you will be saying sir 7 is also there because rest we have already checked. So 3 से भी कम ही आना था, या 7 पे देख लेते हैं. Let's check at 7. So length equals to minimum of 8 comma 7, which is 7, and width is equals to this one and this one. 8 minus 1 equals to 7. Area equals 7 times 7, 49. So you can see that this is the maximum area that we can get, or you can say area equals to the water content as well. No? So this is a maximum amount of water that we are gonna be able to contain here. Okay, as you can see here also answer was 7 multiplied by 7, 49 only. Okay, so I hope this is now clear how this approach is working, the naive approach, the brute force approach. And now I really want you to focus upon what is the time complexity for this solution, though it is quite clear if you were in the first class, and here also. Now you can see there are n items, or you can say n lines, boundary lines. For every line we are finding area with rest of the n minus 1 line, worst case. Okay, so that's why time complexity is becoming what? Big O of n square, because outer loop is also running for n times big O of n, inner loop is also running for n times. So time complexity would be what? Big O of n multiplied by n, which is nothing but this one. Okay, now about the space complexity, because we are using the variable only, nothing much है ना, कोई ऐसा comparable space comparable to the length of the input, size of the input is not what we are using. So that's why space complexity would be constant here. So please remember this approach is order n square and order 1, order n square with time and order 1 for the space. Now let's come to the second approach, the 2-point approach. Why we are gonna use? Let me first give you the idea, because every optimization is done once you have found a pattern, है ना, because naive ways anyway you brute force you are able to apply and solve the question, but how to optimize it? Optimization done by finding the pattern. Find the pattern. Pattern क्या है अभी? As no 2-pointer, so we have been using it more like putting this is 0th index first, 2nd, 3rd, 4th, 5th, 6th, 7th and 8th, correct? And you can say that we take one left pointer and one right pointer. Okay, that's what we usually do. Now don't you think that these two are also will also make a boundary wall, है ना? एक तो यहाँ से लेफ्ट से बन रहा है, एक राइट से बन रहा है. So what would be the area of this container? So length क्या हो जाएगा? Length would be minimum of height at L and height at R, correct? So that would be what? Minimum of 1 comma 8 would be 1. Width would be what? 8 minus 0 equals to 8. So area would be what? Area would be what? Area would be what? 8 multiplied by 1, 8. Okay, till now this is completely okay. So you can say that max area equals to 8 for now. Now यहाँ तक तो सबको क्लियर है कि 2 पॉइंट लगाया तो ऐसा कर देंगे. But how to decide, I mean the next step, how to decide which pointer to move now. Now to decide that, you can understand that what is my objective, what is my objective, objective is, what is my objective, find maximum area, because that is equivalent to the water also. Area kitne component, how many components are there, one is the length and one is the width. Now look at this, simple math hai, correct. Area equals to length multiplied by width. If you apply simple mathematics to increase the value of area, है ना, to increase the value of area, the most ideal situation would be length be maximum there, width be maximum there, then you can get the maximum area. But here, after finding the first area, anyway we are going to move either left to right or right to left. These pointers, left pointer to the right hand side or right pointer to the left hand side, we are gonna move. In either of the situation, what is happening, if we move, width is decreasing, yes or no, width decrease कर रहा है, which is inevitable, होना ही होना है. So if I am not able to make a scenario where I can increase length and width as well, width तो decrease होना ही होना है, width नीचे जा रहा है. What is my only option? My only option to focus on increasing the length, yes or no? Focus on increasing the length so that I can get the maximum value of my area. That's the only way, because अगर ये घटा तो इसको तो बढ़ाना ही पड़ेगा. This is not the ideal situation, but this is the situation, so you would have to work upon this. So now this gives you the logic. Move pointers in expectation of increasing the length. Now how to decide? As you know, you started from the extreme ends, and left, extreme left, and this is extreme right. So right में इससे बड़ा कोई हो नहीं सकता. There is no one longer than this right one, है ना, and there is no one longer than this one in the left hand side, कोई है ही नहीं. तो extremes हमें clear है. Now which direction to move over this point and this pointer would be dependent upon which one is minimum among height, or you can say if height at left pointer is less than, है ना, height at right pointer, then left plus plus. Why? Because right pointer is already at the longest boundary or longest line. So if somehow by moving the left pointer with an expectation कि आगे मुझे I will get some taller line, then the area of my container might be increased. With this possibility, we move over left pointer and vice versa. Vice versa means अब अगर लेफ्ट बड़ा होता है राइट छोटा होता है तो हम राइट को मूव कर रहे होते हैं. दैट्स व्हाट द आइडिया इज. सो नाउ यू कैन लेट्स हैव अ क्विक, आई मीन try run about this. Let's have it. एक क्विक ड्राई रन कैसा होगा? You can see the values here. I hope this is visible. You can see the values here. What are these values? If at the left pointer, which is at the 0th index, and the right pointer, which is at the 8th index, you can see area would be minimum among the left height of the left and right pointer, which is 1,7. Okay, 1,7, height is 7 ना, यहाँ पर दिया हुआ है 1,7. So 7 would be there, multiplied by the width, which is 8. 8 minus 8. What is the answer? What is the answer? Actually, we don't need to multiply it because we are not finding the area, we are comparing it right now. Okay. We are comparing to do what? We are comparing to do what? We were comparing, correct? We were comparing to do means लेफ्ट और राइट को मूव किधर करना है. सो मिनिमम तो 1 था मल्टीप्लाइड बाई 8, दिस वुड गिव यू 8, बट वेयर टू मूव द पॉइंटर्स नाउ. नाउ यू कैन सी दैट minimum length is from the left side, so we will move the left pointer. So left would be kept from here to here, one pay. Now here we can try to find what is the area now between the left and the right. So the height is 8, here also height is 7. Okay, minimum among these is 7. So 7 यहाँ पे multiplied by width. What is the width? 8 minus 1 which is 7. So 7 तो 49 मिल जाता है. Okay, so max area would be updated as 49. Then which pointer to move? Now you can see that among the 8 comma 7 means the height 8 and 7 which is the minimum this, so we can move our right pointer in the expectation that I will get some taller line later, है ना. So I will put the move the right pointer, it will be moved here. Now I am at this position. Now again I will find the area between these. As you can see, this is the logic, that's how we are gonna do. Move the left and right pointer, the idea is clear, है ना, कि whichever height is smaller, move that side's pointer. Okay, that is clear, and that's how we will keep calculating the area and storing it in our max area variable. Okay, and once everything is done, you can see from the last session also, if you remember, these are converging, left and right pointers are converging. And till where are they gonna converge? Till where are they gonna converge? So obviously a boundary wall is created by what? Only when there are two walls, if they both point, let's say अगर left and right यहीं पे point कर रहे होते हैं, left and right are pointing at the same position, means there is no containers being created, correct? So that's why in this code what you are gonna do is you are gonna put this condition, left should be less than right. Okay, not equal to right. So left is 0, right is at the last index which is n minus 1th index. Okay, max area is initially 0, 2 pointers we are using. Okay, now length is what we are doing, again same thing is what we are doing, formula is main, minimum of height of left comma height of right. Then width is what we are finding, right index minus left index. Now area, length into width, then again updating the max area with maximum among the previously max area and the current area. Okay, now this is the thing. Now logic for which pointer to move. Okay, this is the logic. What is the logic? If height of left is less than height of right, then move my left pointer, otherwise move my right pointer, that's all. Once it is done, you will re-edit it and do with all the things. That's how you will why I'm not showing it again and again, because this whole idea of calculating the area is same. It's just that the way of picking the boundaries is different than the naive way. We are picking it using the 2 pointers, so that's why I'm focusing upon how the 2 pointers are working here. Okay, so once this is over, you are just gonna return the max area, that's all, nothing else. So now let's talk about the time and space complexity of this solution. Okay, so time complexity would be what? Earlier we were picking one item and calculating the area with the rest of all the items, but here what are we doing? We are doing simultaneously, and we are traversing the array once only. There is no nesting of the items and no nesting of the loop. Okay, here as well. So this while loop is running for big of n times, है ना, इतना ही चल रहा है, that's all. So that's why the time complexity would be big O of n, and space complexity would be what? Here as you can see, we are not using any extra space which is comparable to the order of the input, which is the order of n. only few variables, 1 2 3 variable. Okay, that's all. So that's why space complexity would be constant. So I hope this is clear. Now let's have a quick comparison among the two approaches. Brute force was taking order of n square time and order of one space. Okay, learning purpose it is okay, but as you know this is a simple question, so we need to optimize as well. In optimization we use two pointer, and the time would be reduced to the linear time. This is a polynomial, this is linear. Space is same, so no issues. So in interviews and real systems, this is how it is done. Okay, interviews में आपको start to, I will say, always start with a nice solution, because it is always better than not giving any solution. Okay, then try to improvise. That's how things are done. Now two pointers reduces from quadratic to linear time while maintaining constant space. Okay, so let's move to next problem. Yeah, this is the one where you need most focus, है ना, need to put most focus that you can give, because there are three approaches, and moving from one to the other, it will take quite a bit of your attention. Okay, so please focus here. Now let's have it. The problem is n non-negative integers are given which represent elevation map, or you can say height. Okay, compute how much water it can trap after raining. So let's consider that if the input is given in this form, the height is given, the first item's height is 3 0 1 0 4 0 2, like this. Okay, so what is the amount of water they can trap after raining, the maximum water that they can trap after raining? Let's say this was raining, so obviously trap after raining tells you what? Trap after raining tells you that कुछ तो सिमिलरिटी लास्ट क्वेश्चन से, कंटेनर्स लाइक स्ट्रक्चर होना चाहिए. यस और नो? मीन्स बाउंड्री वॉल्स. ऑलवेज रिमेंबर बाउंड्री वॉल्स. ठीक है, दिस इज द थिंग, दिस इज द पैटर्न, दिस इज द, यू कैन सी द पॉइंटर्स that you need to understand and catch from the understanding of the previously solved questions and apply it on the new question. You know, कि because there are too many assumptions that needs to be done, too many imaginations that needs to be done while solving things. Okay, so now look at this here. So let's say and for these structures you can say these numbers, let's say these numbers represent the height of the building, because anyway they are representing height, so height of building क्या लेते हैं. Okay, और वॉल्स कह लो, आप कुछ भी कह सकते हो, वट एवर वर्क्स फॉर यू, यू कैन कॉल इट. ओके, सो नाउ यू कैन सी दैट दिस इज द जीरोथ, फर्स्ट, सेकेंड, थर्ड, फोर्थ, फिफ्थ एंड सिक्स्थ बिल्डिंग. ओके, नाउ द हाइट ऑफ द जीरोथ बिल्डिंग is what? 3 is given here, this one's 0, this one's 1, this one's 0, this one's 4, this one's 0, this one's 2, है ना. So can this building trap any water? As you can see, no, this can't trap any water, है ना. Why? इसकी तो बाउंड्री नहीं बन रही, नो बाउंड्री फॉर दिस. यस और नो? कोई बाउंड्री बनी नहीं रही इस बिल्डिंग की. सो बिकॉज इट इज़ द लेफ्ट मोस्ट बिल्डिंग, कोई बाउंड्री नहीं बन रही है. सो लेट्स मूव टू द नेक्स्ट वन. फॉर दिस बिल्डिंग द हाइट इज 0, but to contain the water this building must be surrounded in the left hand side and the right hand side by some building, ना कुछ तो टॉलर होना चाहिए यहाँ पे. तो ये बिल्डिंग कितना मैक्सिमम वाटर ले सकता है? यू कैन सी दैट, है ना, यहाँ कितना मैक्सिमम वाटर आ सकता है? ऑब्वियसली इतना पानी आ सकता है. यस और नो? सो for this particular building left wall is created by this building in the left, but the right wall would be created by what? राइट वॉल कितने पे क्रिएट होगा? ऑफ कोर्स द मैक्स लेंथ इन राइट हैंड साइड. यस और नो? यस और नो? सो यहाँ कितना आ गया? दो लेफ्ट में 3 है, राइट में 4 है. ओके, सो बाउंड्री कितनी की बन सकती है? बस इतने की बन सकती है. मीन्स 3 तक की ना, स्लैंट तो होगा नहीं. करेक्ट, एग्जैक्टली 3 तक का ही हो सकता है. दैट्स वाई द अमाउंट ऑफ वाटर वुड बी लेफ्ट और राइट वॉल में हम लोग इसे देख सकते हैं, ये आ गया, ठीक है, माइनस हाइट ऑफ आई, करेंट हाइट, है ना. लेट मी राइट इट क्लियरली. वाटर इज इक्वल्स टू minimum of left height, right height, okay, minus current height of the building. This also tells you that the current, this building should be smaller than the right and left building. Yes or no? So for this, it was 3 height of the leftmost building, the maximum height in the left, or you can say maximum height in left, maximum height in right. क्या कहते हैं, ये 3 था and this is 4. So minimum क्या है, 3 है. So 3 minus 0 equals to 3 units of water this can store. So let's add it, है ना. Total इज इक्वल्स टू, अभी यहाँ पे हमने 3 किया है, ठीक है. अब आगे चलते हैं, ये हो गया था, ये चेक कर लिया था. नेक्स्ट मूव ऑन हियर दिस बिल्डिंग्स हाइट इज 1, ओके. सो व्हाट इज द लेफ्ट बाउंड्री वॉल फॉर दिस बिल्डिंग. लेफ्ट मैक्स कितना है, लेफ्ट मैक्सिमम हाइट कितनी है, बिकॉज दैट विल गिव इट द, यू कैन से कंटेनर लाइक स्ट्रक्चर. सो यहाँ तो 0 था, बट दिस वन इज अगेन 3. सो again 3, and max in height in right hand side कितना है, that is also 4 again. So among these what is the minimum, 3 minus what is the height of this building, 1 only, 1 equals to 2 units. So कितना हो गया, plus 2 equals to 5. okay, till here it is 5. Let's move on. Here again for this also left would be 3, right would be 4. So 3 रहेगा, 3 minus 0 equals to 3. So plus 3 equals to 8 आ गया, ओके. प्लस 3 equals to 8 आ गया. जस्ट a moment. Plus 3 equals to 8 would be there. Next I am here. So what is the maximum at left, maximum height at left, 3, okay. Maximum height at right, 2. Minimum among these two would be 3, okay. So 3 minus height of this wall, the height of this wall is 4. Now you can understand that this will become negative. So what do you need to do, अगर नेगेटिव होता है, so you don't need to add anything, you can take care of this case, you don't need to add. यहाँ पे कुछ water trap नहीं हो सकता, no water can be trapped here. So just directly move forward. For here, what is the leftmost, you can say maximum height of building in left hand side, this fellow, 4 only. Minimum of left is 4 and right is 2, correct. So this will become 2 minus what, the height is 0, so 2 units of water. So here you can say plus 2 equals to 10. Now move on further. For this minimum of, because for the boundary wall, if I follow this formula, minimum of what, maximum in left, which is this height 4, comma right में कौन है, right में कोई नहीं. So do I need to just for this particular scenario, for the naive approach, do I need to solve for this? No, because in order for this building to contain some water, it needs 2 boundaries, left, one in left and one in right. Left it does have, but it doesn't have in right. So for this also the water content would be 0, है ना. So after this there is nothing, so total water content would be, water trapped would be 10 only. I hope this is clear. Now let's move to how you are gonna code this. So is in the brute force approach, the advantage is you can just code it the way you have thought it directly. Why I'm saying so? Because while looking at this, we just found that there is no meaning in calculating the units of water for the leftmost and for the rightmost boundary walls. or buildings, not boundary, the buildings. Why? Because it needs to trap some water, and for trapping it need to be boundaried from the two sides. The leftmost building doesn't have anyone in left hand side, rightmost building doesn't have anyone in right hand side to trap it. हाइट क्या होगा बाद में देख सकते हैं, बट ट्रैप तो हो ही नहीं रहा है, तो यू डोंट नीड टू सॉल्व इट एटलीस्ट इन द नाइव अप्रोच. ओके, सो वी कैन स्टार्ट सॉल्विंग from the first index to the n minus 2 index, index 1 to n minus 2 index. Okay, because that way you can find maximum height of building in the left hand side and maximum height of building in the right hand side, and then work upon it. Okay, so let's see the code, or let's see the approach. That's our brute force approach. So let me just put it upwards. This is the same thing that I was telling you on the previous page. So what I am doing here is total water is 0. No, this is the first for loop. For loop to do what? Iterating over every building starting from index 1 to n minus 2. Okay, that's why I is starting from 1 and it is less than height dot length minus 1 से भी less means minus 2 पे exactly stop हो जाएगा वो. Okay, now what I am doing is I am taking two variables, left to calculate left max for the particular building and the right max for the particular building. Okay, this loop is find the max element to its in the left hand side. Left hand side में आप कैसे find कर रहे होगे? So let's say my I index is here. I need to go from here till here to find left max, and from here till here to find my right max. That's what I am doing. This loop is running from I minus 1 till 0. This is the 0th index, this is the n minus 1th index. Okay, so I minus 1 till 0 this loop is running and just checking which item is maximum, okay, then my current height. लेफ्ट मैक्स एक बार ऐसे हमने इनिशलाइज कर दिया था. So whichever item is maximum my left and my current height, I will keep updating it my left max, and at the end I will have my left max like here. If I start from here, so is 0 greater than 1? No, so left max अभी भी क्या होगा? 0 रहेगा. Then I move from here to here. I started from here though, here. So now this is height 3, current height is 1. So 3 greater than 1, yes. So left max would become 3. Beyond this is nothing, so this loop will be terminated. Okay, so left to max is equals to 3. Similarly for right max, height is 1 है ना, and यहाँ से हम लोग स्टार्ट करेंगे 0. Is 0 greater than 1? No, so right max would still be 0 because initialized as 0 only. Okay, move to the next item. This one is 4 greater than 1? Yes, so right max would become 4. Still I need to check, so I will go here. Is 0 greater than 1? है क्या ऐसा? Sorry, yeah, left max is greater than height j. That's what we are doing. Okay, so again we are checking. नहीं, राइट मैक्स हमने फिल कर ही दिया ना, सो विल चेक. इट्स 4 ग्रेटर देन 0 स्टिल, है ना. तो ये 4 पे ही रहेगा. देन अगेन आई विल चेक. इज 4 मीन्स आपको मैक्सिमम देखना है ना यहाँ पे, तो लेस भी होगा तो भी आपको डिसाइड करना है, जो भी इन दोनों से जो भी मैक्सिमम हो जाए आपस में वो इसमें पुट हो जाएगा. ओके, सो दैट्स व्हाट वी आर गोइंग टू. सो हियर आई विल चेक अगेन among 2 and 4 which is maximum? 4. So R max would be equals to 4 only. So that's what is happening here. Okay, so that's what is happening here. I was pointing at the right. Sorry, I was pointing at the wrong line. But yeah, the gist is same. That's what I wanted to tell. Okay, this is like this. Now here, now that I have right max as 4, left max as 3, so boundary would be created by minimum of 3 comma 4, है ना? That's how. So that's what we are gonna use next, okay, to calculate total water. But in order to add the total water, the height of the ith index building should be less than, because we are subtracting now, we are subtracting here. That's why I'm confirming, making sure कि it should be less than left and right both, है ना? तभी तो. So that's why if height of I is less than left max and height of I is less than right max, then only we are going inside and doing what? Total water plus equals to minimum of the boundaries. So 3 minus height, है ना? Height क्या था? 1 था, is equals to 2. So that's how at this particular position you can get that this is gonna store 2 units of water. Okay, so this is how this is gonna happen. Now if you can see what is happening here, for every index, I mean from here till here, let me use another pen, from here till here, for every index, for every index, calculating left max and right max combinedly, traversing all n items. Yes or no? Yes or no? These two are combinedly traversing n times traversal. So provided these, time complexity would become big of outer loop multiplied by then inner loop, both are combinedly taking order of n. So that's why big of n square. Okay, and what would be the space complexity here? What would be the space complexity here? Because we are not using any extra space here, only calculation through the variables, order of 1 only. So this is the most basic solution for this. Let's move to the next solution. Next solution is about what? Because see, as I told you, patterns will give you the answer. What is the pattern from the previous solution? Only if we had known for every index, if we had known what is the max left max, and what is the right max boundary, then we can just directly calculate what is gonna be the, how much unit is gonna be the water that is going to be trapped by this building, correct? So that's why we are gonna pre-compute things, okay, do some pre-computation. So what are we going to do is, we are gonna have two arrays actually to store left max and right max for every index, okay, for every index, 0th, 1st, 2nd, 3rd, 4th, 5th and 6th. Don't worry about the logic very quickly, I mean the code very quickly. Let's just have this idea. क्या होता है? If I am here, okay, to get the left max, or in short let me write L max, okay, I can traverse from here to here, है ना? ये काम कर सकते हैं. To get the L max, I can traverse from here to here, correct? How? Let's see how are we gonna calculate while traversing from here to there, okay? For the very first building, what is the left max? There is no other building, okay, because we are gonna use this formula later, okay? That's why let's say that यहाँ पे जो 0th इंडेक्स होगा उसका लेफ्ट मैक्स जो होगा वो सेम ही होगा आइटम जो है वहाँ पे, ठीक है? सो वी विल पुट 3 एज इट इज. नाउ इफ आई मूव, सो अभी फॉर दिस वन व्हाट इज द लेफ्ट मैक्स? लेफ्ट मैक्स वुड बी maximum till here and maximum at this particular position है ना, maximum for previous index है ना compared to height of current index. ओके, सो इसमें जो भी मैक्सिमम हो, तो प्रीवियस इंडेक्स का जो था वो वहाँ पे था ऑलरेडी 3 में पता ही था, हाइट करेंट की 0 है, सो इसका क्या आ जाएगा 3 आ जाएगा. ओके, नाउ इफ आई कम टू दिस अगेन, सो मैक्सिमम टिल प्रीवियस इंडेक्स एंड देन करेंट का कंपेयर करेंगे. सो मैक्सिमम टिल प्रीवियस वॉज ऑलरेडी स्टोर्ड हियर 3 था, सो 3 कॉमा करेंट इंडेक्स का हाइट कितना है 1 है, सो it will be 3 again. Now let's come here again, maximum till this index and then current index. So maximum till this index means second index tak, because we are at the third index. So maximum height in the left was 3 comma current height is 0, so it will be 3 again. For this also it will be 3. Now for this fellow, fourth index, maximum till here and the current. So maximum till here was 3 and current is 4. So which one is max among these? So obviously 4 hai. So we'll put 4 here. Go to next index, this index. Maximum till here and then current index. So it will be 4 comma 0. Current index ka height क्या 0 है. So it will be 4 here. Okay. Now moving to this index, last fellow. Maximum till here compared to this one, so maximum till here was 4 and current index height is, building height is 2, so left max for this building would be 4, you know. So this is how it is calculated. I hope this is clear. Now let's calculate the right. So the way is gonna be same, it's just that now this time we will traverse in the opposite order. ठीक है, but for the same thing. So let's have it. We'll start traversing from here, right hand side. Okay, again यहाँ पे वही होगा, maximum for previous index and height of current index, but because this is the rightmost already, so we'll fill it as it is. Okay, so height इसका 2 ही fill कर देंगे. So instead of starting our calculation from here, we'll calculate from here, है ना, क्योंकि इसका राइट मोस्ट कोई है ही नहीं, there is no one in the right hand side of this. So from here, what is the maximum till here? यहाँ and then current check करेंगे. So we will get what? Let me just remove the previous calculations. So we will get maximum till previous index and current index is height is 0, so max of this would be 2, so we'll put 2 here. Move to the next index, this one. Okay, so here maximum till here and current index, so max of 2 comma previous index पे तो हमें पास ये आ ही चुका था, current is 4, it will be 4, so we'll put 4 here and move on, है ना. यहाँ पे आ जाते हैं. Now for this one, what is the calculation here for this particular index? Maximum till here and then compared with the current height, index of the current height of the current index. Okay, so 4 previously the height cap is 0 है, so it will be 4 ही रहेगा right hand side. And as you can see for this also the right most wall's height is 4 only, so 4 आ गया. ठीक है, फिर यहाँ आते हैं, तो maximum till here and then compared to the current index is height, building height. Okay, so maximum till here was 4 and current height is 1, so it will be 4 only, so 4 fill कर दिया. Okay, then move to this. For this also as you can say 4th and ये 0 है, 4 comma 0 पे हमें max find करना है, this will be 4, so we'll put 4 here. Next come here also maximum till here and current height. So maximum till here was what? 4, current height is 3, so again 4, we'll get 4 here. Okay, we'll get 4 here. Now what? Now you have stored all the left max values and right max values for a particular index, you can see, okay, into extra arrays. The only thing left is calculation. What to calculate? Now here it is. You can see. यहाँ total करते हैं. Total water trapped would be what? अब first set the boundary. Boundary would be minimum of left max of I, comma right max at ith index, ठीक है, minus height of I, ठीक है. So you can see here minimum of 3 comma 4 would be 3 minus current height would be 3, height of index I is also 3. 0 water trapped है यहाँ के लिए. That's correct है ना, वैसे ही होगा. Now for the next calculation. Now you can see the whole logic है ना. So for this first array and second array, what I am doing is I am putting an variable which is having the length of this complete array. Then I am creating two new arrays for left max and right max of the same size as the input. Now I am fixing this zeroth left height as the directly leftmost building's height as height 0, वो put कर दिया. Then I am calculating to fill this whole array. Same calculation, okay. Left max at ith index equals to maximum of left max I minus 1, okay, वहाँ तक, and then current height से compare कर रहे हैं max में. That's what we wrote here, okay. So that's how it is filled. Similarly for the right max also, we fixed the rightmost item by this n minus 1th item, and then we calculated from n minus 2 till 0, okay, having this same formula, okay. That's how we fixed it. Now let's calculate the total units. To calculate the total unit, what are we gonna do is, let's have one more loop to traverse all these three arrays simultaneously, okay. We have all the data, we have pre-computed all the data to calculate this particular thing, the total water trapped. So what are we doing? We are checking if the current height is less than left max and less than right max, then only it can trap. That's why we are calculating, otherwise you won't calculate. So here in this situation, current height is 3. Is it less than left max? No, because 3 is not less than 3. 3 is less than 3 होता है कि नहीं होता है. So what I will do, I will go to the next index. Instead I will go to the next index, है ना. यहाँ से मैं दूसरे index पे आ गया reiterate करके. So here what I will do, height I, which is now 0, less than left max. Yes, 3 से 0 is less than 3. Yes, 0 is less than 4 because here it is 4. Yes, so minimum of left max and right max, which is 3 minus height 3 आ गया. So total water में 3 आपके add हो जाएंगे, है ना. TW equals to 3 कर दिया. Reiterate, I will go to the next index. यहाँ पे again what will I do? I will be doing height 1 है, which is less than 3 and less than 4, and 3 and 4 के बीच 3 minimum है. So 3 minus 1 would be 2. So plus 2 equals to 5 आ गया, okay. That's what is happening. It was this value. Now let's go to the next item and a third index, which is 0, okay. 3 again and यहाँ 4 है, and this 0 is less than both of them. So ये condition true हो जाएगी, and then minimum of left and right would be 3. So 3 minus 0 equals to 3. So plus 3 equals to 8 आ गया. So till here we have got 8 units trapped. Go to the next item. Height is 4, okay. So we'll first check left max and right max both should be greater, है ना. So left is 3, sorry, left is 4 यहाँ पे इसके लिए, and right is also 4. Both are not less than. So what will we do? We will directly reiterate, है ना, और कुछ नहीं होगा, reiterate directly होगा. We'll come here at the fifth index. Item is 0. So again left max is 4, right max is 2. So among these two what is the minimum? 2, है ना. So 2 minus 0 equals to 2 हो गया. So यहाँ plus 2 किया equals to 10 आ गया, okay. That's what this formula would give you. Then reiterate, and I will reach to the last item, this value. Height is 2, left max is 4, right max is 2. Again, this 2 is not less than this 2, so that's why it will not be running, है ना. Then re-edit and it will be terminated क्योंकि अब बाहर आ जाओगे आप. There is no more item to traverse, and then later you can just directly return total water. Total water have value 10, which was the answer. As you can see, 1 2 3 4 5 6 7 and 8 and 9 10. Okay, so that's how it was. Now about the time and space complexity. So time complexity here would be what? You can see this loop is gonna take how much time? Big O of n. This also big O of n, and this also big O of n. There is no nesting, you know. So big O of n plus big O of n plus big O of n, big O of size of n, which is again equivalent to big O of n only, nothing else. Okay, and space complexity कितनी है? Space complexity, though variables are okay, they doesn't contribute much, but you remember these are the two extra arrays of the same size as the height array, which is input array we have taken to store our pre-computed data. So big O of n for left max plus big O of n for right max, big O of twice of n, which can be said as big O of n. So time is big O of n and space is also big O of n. Now here, from compared to the previous approach, we were able to reduce the time, but we have taken an extra space. So it is a trade-off, है ना. So order n space भी order n time भी है. So obviously, the interviewer would ask you, I am not satisfied with this completely. So show me one more or one better solution. So what would you be doing then? So you would be doing this last one. Last one is doing what? Last one is focusing upon two things. Major thing क्या है वो? Let's see, 0 1 2 3 4 5 and 6. Okay, these are the indexes. ये क्या focus करता है? Every time when you had this boundary, what you were doing? Every time when you had this boundary, what you were doing? क्या कर रहे थे हम लोग? क्या फॉर्मूला लगा रहे थे? मिनिमम ऑफ लेफ्ट मैक्स और राइट मैक्स, इधर बाउंड्री का मिनिमम ले रहे थे, एंड उसी बाउंड्री से फिर हम लोग टोटल कंटेंट we were able to calculate the amount of water trapped, है ना. minimum of left and right लेके then we were subtracting it, correct. So this tells that we only need ultimately one wall to compare, not just in the literal meaning. Okay, this is some pattern that we have just found here कि एक से भी काम चल सकता है, पता चल गया तो and we want to calculate in order and time. So let's do two-way traversal on comparison with either boundary. ठीक है, which is smaller one, because in previous approach also we saw smaller one से आपकी means capacity create होती है. The capacity of the container or the capacity of water to be trapped was created by the smaller boundary. Okay, so let's see. If I have this left pointer and the one I have the right pointer, so क्या करना है? Left pointer is at the 0th index, right pointer is at the last index. Okay, let's take L max one variable and R max, right max one variable. Okay, initialize them as 0 अभी तो ठीक है. That's what we are doing. Total water TW also 0. Okay, now because it is the two pointer approach, so they should not cross each other. So let's see, you know, abhi left should be less than right. We are gonna do this. Now we need to focus on the smaller boundary. Abhi boundary कौन point कर रहा है? Boundary right now, okay, is being pointed by this left and right pointers, okay, which are left and right. ठीक है, so क्या करते हैं कि first pick which one is smaller. So height of left is less than height of right. अभी तो नहीं है, no, because right is smaller. So work with the smaller, work with smaller. established from last approach. Okay, so we are gonna work with the smallest, and the smallest क्या है, ये है. So we'll come in the else part. Here what are we doing? We have found that right height is smaller, the building is smaller. Now उसका राइट मैक्स देखते हैं क्या है. सो राइट तो राइट मैक्स पे जाएंगे. हाइट ऑफ राइट इज ग्रेटर देन इक्वल्स टू राइट मैक्स है क्या? अगर ग्रेटर देन इक्वल्स टू राइट मैक्स है, बाय कॉमन सेंस ऑल्सो वी इज एबल टू सी जो राइट मोस्ट आइटम है कोई राइट बाउंड्री नहीं, देयर इज नो राइट बाउंड्री फॉर इट, सो इट कैन ट्रैप, है ना. सो दैट्स वाई व्हाट वी आर गोइंग टू डू, देन वी विल पुट इट एज द राइट मैक्स. That's what is happening. So if height at right, okay, height at right is 2, which is 2 is greater than equals to right max, which is 0 right now. True रहता है तो right max equals to height of right. So 2 कर दिया. Okay. Then else तो then होगा नहीं. Then right minus minus, क्योंकि अब और calculation कर नहीं सकते. Then come here and reiterate this whole loop. Yeah, left is still less than right. So now we are checking again. Height at left is less than height at right. Height at left is less than height at right. No, right is still smallest. So we'll come here in the else part again. Now what we'll do, height at right, which is 0, is it greater than equals to right max? Right max is 2 now. है क्या? No, false. So we'll go in this else wala part, and total water trapped is what we are going to calculate. So right max, which is 2 minus height of at right 0 equals to 2 हो गया. टोटल वाटर में सिर्फ 2 आ गया है. राइट माइनस माइनस. सो आई विल कम हियर. बाउंड्री वॉल नहीं छेड़ रहा है अभी, ठीक है. नेक्स्ट रीआइट्रेटेड एंड देन कम हियर अगेन. विच वॉल इज और विच बिल्डिंग इज टॉलर अमंग दीज, लेफ्ट और राइट? दिस टाइम इट इज़ लेफ्ट, है ना. सो ये ट्रू हो जाएगा. हाइट ऑफ लेफ्ट इज लेसर. नाउ हियर हाइट ऑफ लेफ्ट इज ग्रेटर देन लेफ्ट मैक्स. दिस इज बाउंड्री, है ना. सेम आइडिया होगा. येस, it is greater because it is 3 greater than equals to 0. Yes, so that's why left max equals to height left. So अभी यहाँ पे 0 से 3 आ जाएगा. Okay, left plus plus will go here and then reiterate. if चल गया else नहीं चलेगा ये वाला. Okay, here again, so here left is 0 and right is height is 4. so again ये true हो जाएगा. Okay, now height at left is greater than 0 is greater than equals to left max, which is 3. No, so we will go in the else part. We will calculate the water. Water will do what? Left max minus height left. Left max is 3 minus height at left is 0 equals to 3. So ये प्लस हो रहा है यहाँ पे, प्लस इक्वल्स टू. सो दैट्स वाई 2 + 3 5 हो जाएगा. ओके, देन रीआइट्रेट किया, लेफ्ट प्लस प्लस चले गए, यहाँ आ गए. सो अगेन लेफ्ट एंड राइट की हाइट मैच होगी. Again left is smallest, so what we will do, will come here. Okay, height of left is greater than equals to left max है क्या? नहीं है, because height is 1 greater than equals to 3 नहीं है. So then I will come in the else part. Total water is left max, which is 3 minus height is 1 2. So 5 + 2 कितना हो गया? 7 हो गया this time. Okay, then left plus plus reiterate. Left is less than right. Yes. Height of left is less than height of right. Yes. Smaller पे हम लोग चल रहे हैं. That's what we are doing. We'll go with the smaller one only. So if height at the left index is greater than left max, height is 0 greater than equals to 3 है क्या? No. So we'll go in the else part. We'll calculate left max 3 minus 0 equals to 3. So 7 + 3 10 हो जाएगा. It will be added. Left plus यहाँ आ गया. Reiterate. Now both are putting the same building, so it can't contain anything. Okay, this would be terminated. After termination, just return the total water. So this 10 would be the answer. Okay, now here you can see when we started two-way traversal, है ना, two-way traversal using 2 pointers, then we were able to solve it very optimally. But you can't reach to this solution directly without solving these approaches, because these two approaches gave you the pattern of focusing upon the minimum thing, कि आपको मिनिमम पे आना है. ये जो फॉर्मूला था ना, इस पे आना था. जो मिनिमम होता था वी यूज टू फोकस अपॉन इट एंड देन हाइट पे काम करते थे. सो दिस पर्टिकुलर फार्मूला गेव दिस पैटर्न कि एक बाउंड्री पे ही फोकस करके काम किया जा सकता है, बट पिक इट द मिनिमम वन. ओके, पिक द मिनिमम वन. So moving on, what would be the time complexity here? This time the time complexity would be what? Big of n only. As you can see, one loop, though it is left and right pointer, but we have traversed all the items here, है ना? So big of n, one time full traversal, nothing else. Space complexity, no extra space other than the variables, which would be constant space now there. So this is why this is the most optimal solution for this. And ये difficult question there. This category is, this approach is a difficult one. So you can't reach here directly. So please try to revise, when you're revising this particular lecture, try to understand it on your own also. Please go through the proper steps, okay? Otherwise you might not be able to figure out why we are taking this approach कि पहले छोटे पे क्यों जा रहा है, why are we checking which one is smaller and then keep working with the smaller one only, है ना? So that's how things are. Now let's have a quick comparison of time complexity. Brute force was giving me order of n square and space order 1, but then pre-computations were giving me order n both for time and space. So it was a decent trade-off, but this is the optimized one. Order and time, but space was completely optimal, which is constant only. Okay. So 2 pointers provide optimal space uses without sacrificing time complexity in this case. Okay. Now, when to use 2 pointer for optimization? So we have, according to the questions we have solved, according to that, when maximization problem is there, like container thing, okay, water trapping scenarios, sorted array constraint or order 1 space required, then also, and then greedy choices possible. Okay. Advanced pattern क्या होंगे? That we have learned today. Container pattern, move shorter pointer, track max. Okay. Then rainwater pattern, track max from both ends and calculate the difference. Okay. That's what we have covered. Now real interview questions क्या पूछे जाते हैं usually? So this question was asked in the Google, container with the most water, which we have solved. Then trapping rainwater also, which we have solved, order 1 space के साथ. Then in Microsoft also maximum water container in histogram. Similar है, थोड़ा सा twist आता है, and we will see when we learn stack how we can solve using stack also. Okay. Then meta, both problems were frequently asked in the phone screening rounds. Okay. Now today's takeaway पढ़ तो लिए हैं, but let's see कि क्या क्या कर सकते हैं. Right, the same thing. Container with most water optimization हमने किया है. Trapping rain water with order 1 space. Advanced pointer movement लॉजिक कर लिया. Greedy algorithm intuition हमें जनरेट हो गई है. Why? Because we were greedy about कि कौन सा boundary small है, and that's how we got a pattern and then we started solving. Okay, real interview patterns हमने देख लिए. इसमें सिंपल और कौन से क्वेश्चन आते हैं. Transformation of the time constant and other things we have seen already. So I hope this is clear. Now about the homework. So you can probably solve these kind of questions on the lead code, okay, as a homework, because this will build your strength in terms of solving, है ना. जो कर लिया हो तो आप directly solve कर रहे हो. What I have not shown you, you can try solving it on your own as well. Okay. These two I want you to work upon it and we'll discuss later. Don't worry if you're not able to solve it once. Now please do subscribe to our Aarush Coaching Classes for daily advanced DSA patterns. If you like it, multiple optimization approaches we give, real company interview questions, progressive learning path है. Okay, so if you like our video, if it makes sense to you, if it is helping for you, please do like, subscribe and share for it. Okay, and your engagement just really help us creating more advanced content. Okay, and we will bring more company specific patterns and problems for you. So please bring this up and let's catch up later. Tomorrow we will try to solve these questions, threesome and ksum problems, and handling duplicates and array problems. Okay, so multi-pointer technique would be discussed in this particular question, don't worry, and more farm level challenges would be there. So final thought from my side would be, people, great programmers see patterns where others see problems. यही होता है. Pattern is the thing that you need to recognize, then फिर तो solution simple हो जाता है. Okay, so don't worry, we'll reach there and it's just a matter of practice. Okay, let's see you next session.